I'm Lakshmi. Let me get into the teaching part directly. Today we are going to discuss about a small topic by name phenols, which comes under hydroxy derivatives. Actually, we know what are hydroxy derivatives, right? The compounds which contains hydroxy groups, OH groups. They are going to be called by the name alcohols. Okay. Since that OH group is called as hydroxy group, the name comes under hydroxy derivatives. Okay, so in that hydroxy derivatives, we are going to go with phenols. Phenols go like this. In a benzene ring, when a OH group is directly attached, in a benzene ring, when a hydroxy group is directly attached, then such compounds are going to be called by the name phenols. Okay, let me share a small screen with you now. Let me share a small screen now. See, just going for the first part. We have hydroxy derivatives. In this phenols, we can say that when a hydroxy group is directly attached to the benzene ring, then we can call such compounds by the name phenols. Right? We say that its formula is going to be C6H5OH. Compounds in which hydroxy group is directly attached to the benzene ring. These set of compounds, right? A benzene ring where a OH group is directly attached. Such compounds are going to be called by the name phenols. Right? Its formula is going to be C6H5OH. Right? See, when we take this phenols, why we must learn this phenols under a separate category? Everyone will have that thought, right? Because hydroxy derivative itself is a very big concept. That why should we learn phenols separately? That is because see these phenols have applications in many areas. For example, when we take phenol, it can be used both as an antiseptic and also disinfectant. What makes the difference between this antiseptic and disinfectant? See, antiseptic means suppose when we fall down, right, and we get hurt, that there are some wounds, then we apply Dettol, right? That Dettol is an antiseptic, right? So suppose if the substance can be directly applied to the living tissues, then it can be called as an antiseptic, right? And we use toilet cleaners, floor cleaners, right? Like Lysol, or what is it, Domex, right? All those will be called as disinfectants. The main difference is the percentage is difference. When there's an antiseptic, its concentration would be 0.01, which means that the remaining 99.9% is going to be water because they are applied directly to our living tissues, right? And similarly, this phenol is a disinfectant, means when it is applied to the toilet cleaners or a floor cleaner, it can be called as a disinfectant. We can say that 1% of phenol is a disinfectant. It is also used as a germicide. Germicide means it kills germs. Therefore, phenol is also used as a germicide. And when we take this phenol formaldehyde resin, we have a resin by name phenol formaldehyde, which is commercially called by the name bakelite. Bakelite, Bakelite, bakelite. It is a thermosetting plastic, a high quality plastic, which has a wide variety of uses. Since it has wide variety of uses, we go for this phenols. Right? So how to prepare this phenols? We have many methods for preparing phenols. Okay, we have many methods of preparing this phenols. The first one is going to be Douse process. And the second one is going to be cumene, from cumene. If we say that from cumene, that can be called as the industrial preparation of phenol. Industrial means it will be profitable. That's the main thing. Other process, they can be just prepared in the lab in small amounts. Okay, from cumene is going to be the industrial preparation. And the last one is going to be from benzene, diazonium, chloride. These are the three main methods. Of course, we have some other methods too. So in this session, we are going to see these three methods of preparation of phenol. Okay, so that is, we'll just recall phenol, water phenols once again. When a hydroxy group is directly attached to the benzene ring, then such compounds are going to be called by the name phenols, right? See, these phenols can be classified into monohydric phenol, dihydric phenol, and trihydric phenol depending upon the number of hydroxy groups. If it contains one OH group, monohydric phenol, two OH group, dihydric phenol, three hydroxy group, trihydric phenol. That's it. So because of its wide variety of industrial applications, these phenols are learnt under a separate topic. Okay. See, now we'll see these preparation process in detail. Right? Let me stop sharing and let me share a whiteboard with you now. Okay. Right, getting back. Right, getting back. I told you three methods. Douse process, from cumene, and the third one is going to be from benzene diazonium chloride. Let's get into this Douse process now. See, when I take Douse process, it is mainly prepared from chlorobenzene and sodium hydroxide. Chlorobenzene and sodium hydroxide. So, what would be the formula for chlorobenzene? See, from benzene, this is benzene, right? When I take C6H6, when I take C6H6, this is going to be called as benzene, right? Its formula is going to be C6H6. So when I replace one of the hydrogens by Cl, this becomes chlorobenzene. This becomes chlorobenzene, whose formula is going to be C6H5Cl. Let me go once again. See, this is benzene, right? C6H6. In each H, allow one carbon, one hydrogen. Allow one carbon and one hydrogen. When one of the hydrogens is replaced, I'll get C6H5Cl. So what we must understand is, when I place a Cl over here, one hydrogen is replaced. One hydrogen is replaced. That's it. See, we'll take chlorobenzene. I make it react with sodium hydroxide. I make it react with sodium hydroxide. Okay, just assume this Na and this Cl will get attracted over each other and it will go out as NaCl. It will go out as NaCl. We have to go for the product now. We have to go for the product. See, when we go for the product, we get it as C6H5OH plus NaCl. This is a phenol. Why do we call this as a phenol? Because a hydroxy group is directly attached to the benzene ring. Therefore, we call it by the name phenol. Right? Okay. See, but for this reaction to occur, we apply a high temperature of about 623 Kelvin, and we apply a high pressure of about 300 atmosphere. Why must we apply such a high temperature and high pressure? Actually, phenol is reactive, right? It is highly unsaturated because it has 3 pi bonds with it. So actually, it must be highly reactive, and immediately I must get phenol and sodium chloride. See, why this happens is the Cl minus has been replaced by OH minus. Usually, this benzene ring is said to be electron rich. Therefore, electrophilic substitution reaction must take place easily. Electrophilic substitution reaction must take place easily, right? But this becomes this here Cl minus is a nucleophile, right? Nucleophile means nucleus loving species. Such species will be called by the name nucleophiles. Cl minus has been replaced by OH minus. Cl minus has been replaced by OH minus. Therefore, this becomes an example for aromatic nucleophilic substitution. So let me go once again. Usually electrophilic substitutions reactions are normal, right? Because it's highly electron rich, right? But this Cl minus is a nucleophile. So it is strongly bound to the benzene ring. We cannot remove it so easily, right? Therefore, to remove that Cl minus and replace it with OH minus, we supply a high temperature of 623 Kelvin and 300 atmospheric pressure. Okay, and this process is called by the name Douse process. Okay, it was found by that scientist, Douse, right? So just to honor him, the process is named as Douse process. So these reactions are very important because it comes under naming reactions. It comes under naming reactions. Okay. So going to the next part. The second preparation is going to be from cumene. It is going to be from cumene. First, we must know how to prepare that cumene. Cumene, just only that name is tough, right? But that cumene is nothing but isopropyl benzene. That is nothing but isopropyl benzene. Okay, so this is Douse process. So going for the next process, we go for from cumene. So cumene is nothing but isopropyl propyl benzene. Let me go for it first. We'll take benzene, right? So this is going to be benzene. This is going to be benzene. We make this react with propylene, whose formula is going to be CH3 CH double bond CH2. This is going to be propylene. Okay, see when this reacts, we'll get like this. CH, CH3, CH3. This is called by the name cumene. Right? This isopropyl benzene is called by the name cumene. Right? So we just go for the preparation of cumene once again. It's just an addition reaction, right? We take benzene, we make it react with propylene, right? When we make it react with propylene, the double bond gets broken and it gets added up. The CH3, CH3, second carbon have something. That's why I told you the name was isopropyl benzene. Now this cumene must be converted to phenol. This cumene must be converted to phenol. See, for that we take, again I take cumene. Again I take cumene. Right? Again I take cumene. CH, CH3, CH3. This is the isopropyl benzene, right? See, we make this undergo air oxidation. We make this undergo air oxidation. When we make this undergo air oxidation, the CH becomes COOH. CH becomes COOH. Then go for the product name. Go for the product. COOH, CH3, CH3. This is called by the name cumene hydroperoxide. Cumene hydroperoxide. That's why I have just changed the topic, right? CH3, CH3. This is the compound. Actually, in the last reaction, we had CH3 over here, right? Just to make the reaction, I have taken the methyl group to the top. Anyway, in both the reactions, the methyl group was attached to the same carbon. So it makes no difference. So we need not worry about it, right? So when this isopropyl benzene is made to undergo air oxidation, we get this cumene hydroperoxide. So the next step, what we do is, we take this cumene hydroperoxide, okay, and we make it undergo acid hydrolysis. See, what does this acid hydrolysis mean? We hydrolyze a compound in the presence of an acid. That's what acid hydrolysis means, right? So we make it undergo acid hydrolysis. See, in this, when we make it undergo acid hydrolysis, the compound gets just broken into two. The compound just gets broken into two. So just find out what are they? We have CH3, CO, CH3. CH3, CO, CH3. Acetone. CH3, CO, CH3 should be called by the name acetone, or we can call it by the name dimethyl ketone, or we can call it by the name propanone. Right? There are plenty of names for it. So apart from that, I have phenol. So we have prepared phenol. So it is just prepared in 2 to 3 stages, right? So let me go once again. First, we start with benzene. We make it react with propylene. We get a product isopropyl benzene. This isopropyl benzene is commercially called by the name cumene. This is commercially called by the name cumene. Next, this cumene is made to undergo air oxidation. When this cumene undergo air oxidation, we get cumene hydroperoxide. Next, this cumene hydroperoxide is made to undergo acid hydrolysis. That the acid or water doesn't react, it just helps the compound in breaking into two. So we get phenol and acetone. So this is the industrial preparation of phenol. This is how while they are preparing disinfectant or antiseptic, they go only for this part. Right. So I'm going for the third method of preparation. We go for benzene diazonium chloride. Just in the screen sharing, I showed you a slide. No, I showed you a slide where we had BDC, right? That BDC stands for benzene diazonium chloride. We'll take that benzene diazonium chloride. See, this is benzene, right? C6H6 is benzene. In this benzene, one hydrogen is replaced by diazonium chloride. Diazo always stands for N2. Diazonium always stands for N2. If we have N2, we must call it as diazo, whether it is aliphatic or aromatic or alkyl, whatever it may be. Wherever we have N2, that must be called as diazo, only in organic compounds, right? So, suppose if I have C6H6, it must be called by the name benzene. It must be called by the name benzene. In that benzene, one of the hydrogens is replaced by diazonium chloride. That's why we call it as benzene diazonium chloride. Okay. So this benzene diazonium chloride is made to react with steam. Steam is nothing but water in the vapor state. Water in the vapor state. Okay. See, we have H2O. Let me split this H2O now. H plus OH plus. H plus OH minus. Okay. Now just see what happens. This C6H5 and this OH will go out as C6H5OH. We get phenol. Right? In 99% of the reactions, this enter will go separated. Enter will go separated. Therefore, this enter comes out separated automatically. Only in 1% of the reaction, we have a reaction by name diazotization. Only in that reaction, nitrogen will be retained. In rest of the reactions, this nitrogen will go out. Okay, so we get phenol plus nitrogen plus HCl. So we have prepared phenol. We have prepared phenol, right? So we take benzene diazonium chloride. It is made to react with steam. Steam indicates water in the vapor state, right? So in this, as usual, nitrogen is eliminated. Hydrogen, that is hydrogen in water, and the negative part is this HCl go to this HCl. Rest of things we have C6H5OH, which is called by the name phenol. Still more, we have some more preparations. Okay. We'll see that later. We'll just recall what all we are seeing once again. We'll just recall once again the compounds in which a hydroxy group is directly attached or called by the name phenols. Right? These phenols can be classified as monohydric, dihydric, and trihydric, depending upon the number of hydroxy groups present in that. Phenol, it has a wide variety of uses, right? It is used as an antiseptic, disinfectant, it is used as a germicide, right? It is used in the preparation of a thermosetting plastic by name bakelite, a high quality plastic. So because of its wide variety of uses, we learn phenols under a separate category. Okay. So because of that, it's all its preparation, properties, everything has been discussed. So we have many methods of preparation. In this class, we have discussed 3 methods. The first process was Douse process, which was an example for aromatic nucleophilic substitution. And the second method was from cumene. From cumene was made to undergo air oxidation, which was followed by hydrolysis. We got phenol. And the third one was benzene diazonium chloride. This benzene diazonium chloride is also a very industrially important compound because of plenty of compounds can be prepared from it. Okay, that will be learning in nitrogen compounds, so don't worry about it. Phenol also can be prepared from that benzene diazonium chloride. When this benzene diazonium chloride is made to react with steam, we get this phenol plus nitrogen plus HCl. That's it. Okay, thank you.